Good morning, dear students. I am Dr. Srinivas Battini, Professor of Chemistry. So today we are going to start a new chapter, that is fundamental concepts. So why it is required? The fundamental concepts, what is the reason? Because every day, thousands of organic compounds are being discovered in the worldwide. How it is possible? What is the mechanism is involved? What are the basic rules? If we know all these things, can possible to discover the new organic compounds? Researchers, either scientists or professors, what knows all these things very well. That's the reason. Thousands of organic compounds are possible. Millions of organic compounds. The pharma compounds, the new drug compounds may possible. So all these things depend upon the fundamental concepts what I am going to discuss. It required almost 10 videos. So let's look at the basic concept for organic compounds. What are the basic concepts? Fundamental concept. The chapter is fundamental concepts. So these are very, very important for total organic chemistry. Every student, every chemist, every scientist should know. Without knowing of these fundamental concepts, that's not possible to do anything. Student can get the marks, but scientists or researchers or chemists can benefit to discover new organic compounds. Okay? So what are that? That is the first one is cleavage of covalent bond. How it is possible? What happened? Cleavage of covalent compound. Cleavage of covalent bond. Covalent bond. We know that covalent bond, that is a sharing of a pair of electrons. Covalent bond. Covalent bond is a definition in intermediate. We know just sharing of a pair of electrons is called covalent bond. But how to cleavage is important. The research should know the cleavage of covalent bond. There are two types of cleavage things. Cleavage takes place two ways. That is a homolytic bond fission or homolysis. Homolytic bond fission. That A is called what? Homolytic. Homolytic bond fission. Homolytic bond fission, or simply we say homolysis. Homolysis. It's mean what? The covalent bond is cleaved. The covalent bond is cleaved. And it leads to the formation of odd electron species is known as free radical. Mean the covalent bond, when it is cleavage takes place, so what compounds formed? The free radical compounds formation takes place. The best example, chlorine molecule Cl2. Cl2 is a covalent bond. Covalent bond. That two chlorine atoms. Chlorine atom sharing a pair of electrons to form the covalent bond. This is the covalent bond. This bond is called the covalent bond. Covalent bond. So I will tell you that how free radical formation takes place. These two electrons, the two electrons already I told you in the first class, two electron is equal to one single bond. One single bond. One bond is equal to two electrons. That is the Cl2. So mean here, let's look the chlorine sharing up a pair of electrons. So between two chlorine atoms, two electrons are there. Here the cleavage takes place. Homolytic cleavage mean this electron comes to this atom, chlorine atom, and this electron comes to this. Mean two chlorine atoms get is sharing the cleavage also. So mean Cl radical plus Cl radical. These are the free radicals. So this must import. These are the free radicals. Free radicals formation. Free radical. So this is the what? Homolytic bond fission. Homolytic bond fission. This is very, very important. But in the case of heterolytic compound, that heterolytic bond fission, we can say this is the homolytic and the B is heterolytic bond fission. Heterolytic bond. Heterolytic. Simply heterolysis. That is the homolysis. This is the heterolysis. Heterolysis. What happened here? Mean the covalent bond is cleaved and it leads to the formation of a cation. Formation of a cation and anion. It means one is deprived of its own electron and other species gains both the electrons. Example, see the example. A and B, two electrons. A atom deprived, mean loss of electrons. Mean here A will get the positive, mean loss of electron, deprived electron. And another one B is gains the electron. Gains both electrons. The two electrons it takes here. Mean that is a negative. Two electrons are there. Two electrons. B atom takes two electrons. So mean that is a positive. So cation and anion. Positive and negative. So this is about the cleavage. It's a simple looks, but it's a most useful for the researchers. If any molecules like that homolytic compounds will take, that is a free radical formation takes place in the mechanism, that is very, very useful. And heterolytic, that is a cation takes place, and anion. Anion meaning that containing the two electrons. Always you have to remember in the future chemistry, future organic chemistry, that is a negative mean that containing the two electrons. Mean positive mean, so there is no electron in here, it wants the electron. That means important. So A wants the electron and B donates the electron. That is important. Okay. And the next one we'll see the reagents. The second one is second fundamental concept. Second fundamental concept is reagent. The first is the cleavage. The second one is the what? Reagents. Reagents are very, very important. There are three types of reagents. How many types? There are three types. The first one is the electrophiles. Electrophiles. Second one is the nucleophiles. And third one is the free radicals. Free radicals. These are very, very important. Being researchers, our students or anyone, we have to know the electrophile. What is electrophile? What is nucleophile? What is free radical? Just we have seen the free radical, that is also reagent. The two chlorine atom cleaved. Homolytic fission between the two free radicals. Free radical is a reagent. So now let's look the electrophile. What is electrophile? What is a nucleophile? So first we will see that electrophiles. In the reagent, first one we see the electrophiles. Electrophile. Electrophile mean electron deficient. It's very simple. Electron deficient. Electron deficient. Electron deficient or electron acceptor. Electron acceptor. Electron acceptor. There is no electron mean deficient. Just before you have seen heterolytic fission. Heterolytic mean the loss of electron. One is deprived. Losing one electron mean cation. Positive mean the all positives. Electron deficient. So it always required accept electron. It accept electron. Simply, what is electrophile mean? Electron deficient or electron acceptor is an electrophile. It's simple. It's simple. So in this electrophile, there are two types of electrophiles. Charged electrophiles, neutral electrophiles. They are charged electrophiles. Charged electrophiles. Charged. Charged electrophiles. Charged electrophiles. What are the charged electrophiles? Just before I told you that positive is a charged one. Mean H plus, Cl minus, Br minus, NO2 minus, R3, C plus minus, NO plus, the phenyl plus, aniline plus, SO3H plus, for many examples. But except cations, but the first year and second year group elements and ammonia. Except what? First year, second year and NH plus. Except these all positive ions. Example, H plus, Cl minus, Br minus, Br plus, Cl plus, Br plus. They are required electron deficient. NO2 plus, R3 mean carbonium. For example, R is the alkyl. So this is also C plus R3. NO2 plus, NO plus also there. NO plus. If we can take aniline, that is a C6H5 and C6H5 into diazine. C6H5 N2 plus or SO3H plus. SO3H plus. So these are charged electrophiles. All are charged electrophiles. But always remember that is first year group elements like sodium plus, potassium plus, magnesium plus second year group. So these are not electrophiles. These are not electrophiles. And ammonium cations. These are not electrophiles. Charged electrophiles. Okay? Remember. And carbocations also. C plus carbonium ion. Carbocation. That is electrophile. So always remember, all cations are electrophiles except first year, second year and ammonia. So please remember all these things. And neutral electrophiles. What are the neutral electrophiles? Neutral covalent compounds. Neutral covalent compounds, which is the central atom has incomplete octet rule. and expand due to the presence of empty d orbitals. The presence of empty d orbitals. Neutral covalent compounds. Just mean here we have to see that second one is the neutral electrophiles. Neutral electrophile. What is that? Charged is over. The second one is the neutral. The A is the charged electrophiles and neutral electrophiles. Neutral electrophile in NEU. Neutral electrophile. So neutral covalent compounds in which the central atom has incomplete octet rule. Octet rule means that is incomplete. Every compound should be incomplete. So what type of compounds that compounds are important? Example, we have to know incomplete octet rules. That is especially beryllium chloride, BeCl2. Examples are important. That is the neutral electrophiles, charged electrophiles and neutral electrophiles. So neutral electrophiles are beryllium chloride. Examples are beryllium chloride. BH3, we know BH3 and ALX3. X is the halogens, Cl, Br, aluminum chloride, aluminum bromide, aluminum fluoride, like that. These are also incomplete. And CH2, carbene, incomplete. And CX2 also, CX2. One CCl2, CCl2, CBr2, C iodide, like that. And tin chloride, silicon tetrachloride, tin chloride, silicon tetrachloride, tin chloride, SnCl4, SiCl4, tin tetrachloride, silicon tetrachloride, phosphorus pentachloride, SF6, PCl5, SF6, sulfur hexafluoride, and IF7, BX3. BX3 mean boron trichloride, boron trifluoride, boron tribromide, and FeX3, ferric chloride, ferrous chloride. You can say FeX3 mean FeCl3, FeBr2, like this. FeCl3, FeBr3, all FeX3. And PCl3 also, PCl3, phosphorus trichloride. NF3, we can say NF3. Number of carbons, these are neutral compounds are many, neutral electrophiles. Carbon dioxide also there, sulfur dioxide, carbon disulfide, bromine, iodine, all these things are incomplete octet rules. What are that? Carbon dioxide, sulfur triaxide, and CS2, carbon disulfide. We can simply chlorine, bromine, iodine. All these things are what? Neutral electrophiles. Mean either positive, neutral mean positive or negative. Neutral, simply neutral. Okay, but should be incomplete octet rule. So these are about the what type of new electrophiles? Neutral electrophile. And charged electrophiles already you know that is a positive charge is there. Okay, now electrophiles are completed. Now see the nucleophiles. Okay. Nucleophiles. So what about the nucleophiles? So what is meant by nucleophile? So simply nucleophile means electron rich or electron donor compounds are called nucleophiles. What are that? Nucleophiles. Nucleophiles mean electron rich molecules, electron rich. They are having plenty of electrons. They are ready to donate the electrons are called nucleophile. So simply we can say all Lewis bases are nucleophiles. All Lewis bases. We know the Lewis bases. Acid base theory. Intermediate second year. 12th class second year. That is Lewis acids and Lewis bases. So simply we can say all Lewis bases are nucleophiles. They are charged nucleophiles. What type of charge? The negative charge. Charged nucleophiles. Charged nucleophiles. Charged nucleophiles. They are H minus. Charge means H minus, O minus, OH minus, H minus, OH minus, RO minus, like that. NH2 minus, R3 minus, R3 carbons, R3 carbon minus, and SH minus, SO3 minus, SO3 minus, N3 minus, Cn minus, N3 minus, SOR minus, and RCOO minus. You can say RCO minus, RS minus. We can RS minus also there. RS minus. Many compounds are there. So all these compounds are act as what? Charged nucleophiles. So these compounds are act as what? Charged nucleophiles. And neutral nucleophile. We have seen the neutral compounds. Please note down all these things. Neutral. What is that? Neutral nucleophiles. Neutral nucleophiles. Neutral nucleophiles. What is meant by neutral? All neutral molecules containing at least one lone pair. One electron atom act as nucleophiles. One lone pair on central atom. Lone pair means this is the lone pair. This is called a lone pair. On central atom. I will tell you few examples. NH3, nitrogen containing the 2 electron. Or NH2, nitrogen containing the 2 electron. Central atom. For example, NH3, ammonia. This is the nitrogen containing 2 electron. This is the neutral electrophile. RNH2, amines. This is also containing the 2 lone pair electrons. Water, simple example. We can say water, H2O. Oxygen containing the 2 lone pair of electron. Ammonia containing the 1 lone pair, or water containing the 2 lone pair electron. Alcohols, ROH. Oxygen containing the 2 electrons. These are all what? Neutral nucleophiles. H2S, we can H2S, RSH, H2S, RSH. So all mean that the pair of electron. pH3, phosphine, we can say pH3, neutral electrophiles, phosphorus containing the electron. Or pH3, or pH2, we can say or pH2. Alkyl group and pH2. and we can say phenylphosphine. This is also containing that electron, phosphorus. So all these containing the central atom, lone pair electron, either 1 or 2 lone pair electron act as what? Neutral electrophiles. Okay, thank you very much. So today what we have discussed the fundamental concept, especially free radical cleavage of bond, that is homolytic is an hydrolytic is an, and the reagent, the second one is we have completed only 2 completed today, that is the cleavage and reagent. In the reagent we have completed the electrophile, nucleophiles and free radical. Okay, thank you very much. Please don't forget about subscription. Okay, thank you very much.